All right, so let's do a brief aside about the. This is like a bad history of reinforcement learning. So it's not that it's a bad history; it's just badly told. So, but the basic idea is this: once upon a time, and we're going to call it, say, the 1930s, people observed that if you put an animal, this is supposed to be a rat, in a box, say, and give it choices of looking in place B and place A, and say one of them has cheese in it and the other one doesn't, but it can't see which because the doors are closed. And let's say that we consistently do something like this. We turn on a red light whenever the cheese is in the A place, and we turn on a blue light whenever the cheese is in the B place. And what you observe is if you do this consistently, then what you find is that if the animal sees a stimulus, like the red light going on, and it takes an action, like peeking inside or sticking its head inside the box A, and it gets a reward, which in this case would be getting to eat some cheese, that setup strengthens its response to this stimulus. In other words, in the future, when it sees the red light, it's going to be more likely to go in and look in box A. And this notion of strengthening, you can think of it as reinforcing the connection. Reinforcing just means strengthening.
Mm.
So this was studied for a long time, and there's a tremendous amount of interesting research about this. But if you start to think about it as a computer scientist, a natural way of kind of thinking about what this problem is that a stimulus is kind of like a state, and an action is kind of like an action, and a reward, well, I kind of stole all these words, but it's kind of like a reward. And it leads you to this idea that really what you want to do is figure out how to choose actions to maximize reward as a function of the state. And so we started to take this concept and we called it reinforcement learning because that's what the psychologists were calling it. But for us, it just means reward maximization. This notion of strengthening is really not part of the story for us at all. So we're really taking this word and using it, wrong.
Well, that all makes sense except for one thing, which is the idea that this happened in the 1930s, because we all know that rat dinosaurs did not exist in the 1930s.
Yeah, they went extinct in the 40s. There's one little epilogue to this story, which I find really kind of amusing, and that is the computer scientists did pretty well at figuring out algorithms for solving problems like this. And the psychologists really do care about how stimuli and motor actions and reward all interact with each other. And they've turned to the computer scientists to say, how might the brain be doing this? What is the problem that the brain actually might be solving? And so guess what word they borrowed back when they started to think about these things? Reinforcement. So now they talk about reinforcement learning, and they don't mean reinforcement either. They mean reward maximization.
So we won.
I don't think that was really our plan, but it's nice to know that we had some impact.
Oh, that's very good. You brought planning back into it, and so they learned because of our plan. That's pretty good, Michael.
All right, so that's the end of this aside.
Okay.
Let's go back to learning things.